Let's take a look at the for loop structure, especially when we're using arrays as inputs. So I'm going to first place my structure and then create an array control device. So I first begin by placing an array, and then I have to place the specific type within that array. So I'm using numeric control for that. And I'll put in 5 values. So I have a one-dimensional array containing 5 elements. Let me place my control outside the loop, and then I will wire the input to the interior of the for loop. I'm going to consider the loop tunnel using the auto-indexed mode, and then set up an indicator for the wire emerging from that loop tunnel. Notice how it's converting an array type to a scalar type. So I'll add an indicator for the loop iterator so we can watch what that's doing. And I'll add some delay inside the loop just so we can watch the behavior unfold here. So it has a delay of 500 milliseconds. Let's run this and watch what happens. So we see that the current value being indicated inside the loop goes from 1 to 5. And so what that's doing is picking off each of the values of my array. So the indexing means that the array implies that the loop needs to run over 5 elements, or the size or the number of elements in the array. Now if I turn off indexing and readjust the internal indicator, since it is now an array type, because now we're simply passing the value of array into the interior of the loop. Notice that the run arrow is indicating a broken VI at the moment, and for the reason it says that there is nothing to indicate the number of times that the loop should run. So we simply pass the value in here, and we would actually need to wire up something to the loop count in order for the loop to operate. So I'm going to send this back to indexing enabled, and we'll put a little bit of calculation inside the loop. What I'm going to do is multiply each value of the array by the value of the iterator. Incidentally, I'm just tweaking the position of that multiply node using the arrow keys when I selected it. Now notice on my output side loop tunnel I have indexing enabled, so that takes the scalar being calculated, stores all those up, and produces that as an output array. So when we run this, we should see that each of the element values of the array gets multiplied by the iterator. Those are then stored as each pass through the loop and then produced as a final output array. Now if I disable indexing, so I'm now passing in an array, I multiply it by an iterator value, a constant, and pass that out as a finished array as an output. Now I need to specify a certain number of times that the loop ought to operate. Let's try running that again. So what we see is that the final pass through the loop is the output that's being generated. Now I'll change the output side loop tunnel to indexed mode again. So that actually increases the dimensionality of our array by a factor of 1. So notice that the output now is actually a two-dimensional array. I need to move this around a little bit so we can see it better. So again, with indexing enabled, what that means is that each pass through the loop, the finished result is saved, and then we see all of those values being presented on the output side. So we see basically our input array gets multiplied by the value of the iterator and then is appended to build up a two-dimensional array. Again, you might need to pause the video and replay this a little bit just to kind of get a sense of how this is all working together. Now, one other technique that is very useful is sometimes we like to be able to take the results of an array computation and actually concatenate them so that way we still have a one-dimensional array instead of a two-dimensional array being formed. So I'm using build array, and it's imperative that you first select concatenate before you actually start wiring to its terminals. So what I'm doing is using my feedback node to take the result of the build array, feed it back around to its own input, and this way each pass through the loop we keep appending a calculation of that multiply node, and so when we're done we still end up with a 1D array. So I have to make sure that I disable the loop indexing on the output loop tunnel. Now we expect to see 5 array elements multiplied by 0, the same 5 elements multiplied by 1, the same 5 elements multiplied by 2, and so on. So now we in fact do see a nice long array here. Let's try to see some more of those values. And if you look carefully at it, I'll just make this a little shorter so we can see those more clearly. Here we see a grouping of 5 multiplied by 0, 5 multiplied by 1, 5 multiplied by 2. This is the initializer terminal, and typically you could set that to a value such as 0, and creating a constant is a nice way to set up a value.